Welcome back to Understanding Python. My name is Jake, and today I'll be talking entirely about lists. Lists are one of the most versatile and useful data structures in Python. Having a strong understanding of how to create and work with lists will be a key part of becoming an amazing Python programmer. And with that in mind, I'm going to give you a solid foundation in Python lists. First, you might be thinking, what are lists? Well, lists are flexible, mutable data structures. What do I mean by that? Well, first, let's go ahead and just put a docstring at the top. Lists, flexible, mutable. Flexible means that you don't have to define the size of a list ahead of time, and you can increase the size of a list as you go along. Mutable means that you can change the contents or values within a list at any point. First, we'll start with making lists. Making lists in Python is easy. If you remember my previous video where I talked about data structures in Python, we made a number of lists. Let's just go ahead and make a basic list right now. We'll call this my list, and the contents will be 1, 2, 3, 4, 5. Easy enough. So we've just created a list. You can make lists with defined values ahead of time, 1, 2, 3, 4, 5, or you can dynamically generate a list using a function like range within Python. So let's go ahead and create a new list called generated and make it equal to an explicit casting into a list of the output of the range function. One thing to remember about range is that while the first number is going to start with that number, so in this case 1, we're going to get the first value of 1, it actually ends one number before the last number. So the output of this is going to look exactly like the list that we have up here, 1 through 5. So let's go ahead and add some print statements and see what this looks like. Print, call this okay, we'll save it and then we will run it. And we see we have my list 1 through 5 generated 1 through 5. Two different ways to generate a list getting the same output. One that you define ahead of time, which is easy enough to do for short lists, but if you wanted this generated list to be much longer, say dozens, hundreds, or thousands of entries long, you certainly don't want to type each of those numbers out. Let's add a new print statement up here just so we can add a little header to our output. Next up, we'll talk about accessing list items. Like most programming languages, Python's counting starts at 0. So in order to access the first entry of a list, you would actually refer to that as the 0 index. So what does this look like? We would go my list 0, my list 3. Another interesting thing you can do with Python is do negative index, which would count from the end towards the beginning. So -1 in this case would refer to 5. If we did -2, that would be 4, -3, and so on, all the way back to the beginning. This is helpful if you just want to get the very last entry in a list. But how do we access elements in a nested list? Well, let's go ahead and take a look at that. Let's create a new nested list. Call this nested list. It's equal to, we'll just start 1, 2, 3. Add a new nested list in here with the first entries being 4, 5, 6, and then we can actually make a double nested list under that with values 7, 8, and 9. Here we have 3 levels of a list. The 0 level, because remember, you want to start with 0. The first level, and then the second level. To access these for particular values, we'd say nested list 2, which would give us the 0, 1, 2. So it would give us the value of 3. Going down further, nested list 3, and then 1 would get us into this initial list with the value of 3, the index of 3, and then inside that, the 1 position would be 5. If we're going to get into this lower level list down here, we'd simply carry on that same pattern. So 4, 0, 2 would give us the value of 9. That's because this list is the 4th position in the outer list. That list only has 1 entry, so we want to use 0 to get the first entry, and then inside that has 3 values. To get the last one, we'll do the length of 3 minus 1 is 2. You could also have made this -1. So I'll go ahead and add some print statements in here, and then we can print this out and go through each of those. Alright, all print statements are in place. Let's go ahead and run this and take a look. Okay, perfect. Under the heading Accessing List Items, we have my list at index 0 is 1, as expected. At index 3 is 4. At -1, we're at 5. Now for the nested list at index 2, we have a value of 3. At nested list of index 3, which is this first nesting here, and index 1, we have 5. And then finally, at nested list at index 4, which gets us into this nested list, and then the 0 element of that, which is the list under that, and then the very last element, which is annotated with -1, we have 9. Perfect. So that's how you access items in a list. Moving on, let's talk about changing values in a list. To change the value in a list, the easiest way is just to reference the index of that entry and then assign it to a new value. So for my list at index 4, we'll make that changed. Let's go ahead and add some print statements and take a look at this. Alright, print statements are in place. We save this and let's give this another look. Alright, we have changing values, and we see that at index 4, which is 0, 1, 2, 3, and 4, that value is now changed. Now let's get into the larger subject of list methods, or the methods that are available to a list object. We'll group these by their functionality. The first in the functionality will be adding to a list. We'll create a new list called adding list. And again, we'll just use the basic values of 1, 2, 3, 4, and 5. Now, the first way you can add a value to a list is using the append method. So we'll do adding list dot append, and we're simply going to put in the value 6. This will just add a new entry to the end of the list that looks like that. Aside from appending single values, you can also append entire lists to it. So we'll say adding list dot append, and we'll make a new list in here that is 7, 8, and 9. So what that will do is after 6 is added, it'll make a new nested list like we saw above that contains 7, 8, and 9. What if you didn't want to nest that 7, 8, 9 list inside of adding list? What if you actually wanted to add the values themselves to the end of adding list? Well, the method for that is called extend. So we'll do adding list dot extend, and in here we're going to do a new list called 10, 9, 8. And what this will do is we'll actually take the values out of this list and put them at the end of adding list. So the end result will be 1, 2, 3, 4, 5. Then we'll have 6. Then we'll have the nested list of 7, 8, and 9, and then the values 10, 9, and 8. Aside from adding to the end of the list, you can also insert a value at a particular index within the list. And the way that we do this is with the method insert. Adding list dot insert. So this takes 2 arguments, the first being index, so we'll use 3, which will be the 4th position. And then the object we're going to insert, we'll say bacon. So we're going to add some bacon into our list. Another way of adding entries to a list is to actually use the plus sign or true addition. So we'll do adding list is equal to adding list plus 12, 13, and 14. It's very important that when you're trying to add something to a list using the plus sign, that what you're adding is another list. If you try to do a single value or say a tuple, that's not going to work. So make sure that it's another list. But what this will do is the equivalent of extend. So it'll add these values, just the values, to the end of the list. A shorthand in Python for this, which is adding list is equal to adding list plus that, is to use the plus equals. So we'll just say adding list plus equals, and then we'll go 20, 21, 22. So this is effectively the same exact statement here as what you see down here. It's just a bit of shorthand, if you will. And then finally, for adding onto a list, you can also multiply lists. So we'll say adding list times equals 2. So what this will do is it will just multiply adding list by itself. And what do I mean by that? It's effectively, if we were to do this, adding list plus equal adding list. So it's just doing adding list and then itself. You can do this as many times as you want. Say you want to repeat a list 20 times, you just add a 0, and now you have that list 20 times over. We'll just keep it at 2 though. Alright, let me add some print statements to this section and we'll see what all of this looks like. Okay, all print statements are now in place. Let's go ahead and run this and see what this looks like. Okay, give us a little bit more room, and we'll start up here with adding. So again, we started with 1 through 5, but here we appended 6, so we just have the single value. Then we appended a list of 7, 8, 9, and you see that now we have a nested list in there. Then we extended a list that contains 10, 9, and 8, and you see that the values themselves were ripped out of this list and added to ours. Then we inserted bacon into the third position, so 0, 1, 2, 3, and you see that bacon is here and everything else was moved over. Then we used addition, or the addition here, to add in 12, 13, and 14, and you see that the behavior is exactly the same as extending. And then similarly we did the plus equals, which did the exact same thing with 20, 21, and 22. Finally, we multiplied the entire list by itself. So we have everything through 22, and then it repeats itself again. 1, everything again through 22. So those are the basics of adding things to a list. But what if you wanted to remove from a list? Well, we have things for that as well. We'll call this removing from a list. Let's make a new list in here called removing list. And just to mix things up very slightly, we'll do 9, 8, 7, 6, and then 5. So the first method that we're going to use for removing something from a list is the method pop. Now what's interesting about pop is that you actually get the item out of it. So we'll call this removed is equal to removing list dot pop, and we're going to pop out the third index. So with this we should get 0, 1, 2, 3. We should get 6 out. And at this point 6 comes out, gets stored in removed, and then the rest of the list just becomes the 4 values that are in there. Another way to straight up remove something without getting anything out is the method remove. So we'll call this removing list dot remove, and we're going to remove the value 8. So what is different about this as compared to pop is that pop looks for an index. So when we said 3, it'll pull out 6. But remove actually looks for the value itself. So we'll search through the list and find the first instance of that value, and if it exists, it will remove that from the list. Just taking it out doesn't really give you anything. Another way to straight up remove something or delete it is to use Python's del method. This isn't anything unique to lists. This is how you actually delete objects in Python. So we'll say del removing list, and we'll take out the very first index. And then finally, say that you are done with the list, you want to explicitly remove everything from it, you can use the clear method. So removing list dot clear. So this doesn't take any arguments, it just simply clears the entire list, whatever was in it. Alright, let's add some print statements and see what all this looks like. Okay, we're back. The print statements are in place. The file is saved. Let's see what happened. We started with 9 through 5 in reverse order. At the top, we see the popped value was 6 because it was pulling from the third index. After the pop, the list no longer has 6 in it. And then after we removed the value 8, you can see that 8 is gone. Then we deleted the first element of the list, which now leaves us with 7 and 5. And then finally, we cleared it, leaving us with an empty list. Perfect. So now let's talk about changing or mutating a list. So as you expect, there are a few methods that are available to list to mutate the value in it. So for this one, we're going to call this mutate list. And instead of explicitly typing out a list, we're going to use the casting of list range, and this will be values from 0 to 9 because our range stops, if you'll remember, one value before your ending here. So the first change we're going to make to the list is to reverse it. And we'll do this with, you might have guessed it, the reverse method. So we'll say mutate list dot reverse. So now instead of having 1 through 9, our list will look like 9 through 1. If we want to sort a list, we can do mutate list dot sort. And by default, this will do the values from lowest to highest. Now, if you wanted to reverse the sort, you can do that as well. So we'll do mutate list dot sort, and then specify a keyword in here called reverse, and make that equal to true. So now we again are going from 9 to 1. Now we can do sorting is with the sorted method. So mutate list is equal to sorted and then mutate list. With sorted, you can also reverse that, but I think this list has bounced back and forth more than enough for this example. All right, I'm going to put in some print statements so we can take a look at what's going on. Okay, we're done with our print statements. Let's run this and take a look. Okay, we started with a list from 0 to 9. Excuse me, I misspoke earlier. When you use range without specifying a first starting point of 1, it will again start at 0. Python counts from 0. So our first list started with 0 through 9, but after we reversed it, we get 9 through 0. Then we sorted it, getting 0 through 9 again. Then we reversed that sort, bringing it from 9 to 0. And then finally, we sorted it using the sorted function, and then we ended up with 0 through 9. All right, now that we've talked about basics of mutating a list, let's talk about getting information about a list. So we'll title this Getting Information About a List. And we'll create a new list called, info list. This time we're going to explicitly type it out to be 3, 4, 5, 5, 5, 6, 7, and 7. This way we have some duplicate values in there, which will be useful in just a second. So the first method we're going to cover is count. This counts the amount of a particular value that's in a list. So we have a few 5s. Let's go ahead and count how many 5s are in the list. And that's simple, just like this. Count and then the value. Just as before, when we specified 8 for our remove, we can use 5 as the value here instead of a particular index. So this will go through the list, say 3, no, 4, no, 5, yes, 5, yes, 5, yes, 6, no, 7, no, 7, no. Coming up with 3 as our total. Aside from just counting values in a list, you can also get the total length of a list, or how many entries are in a list, with the built-in length function. So we'll just do len info list. Remember that it's len and not length. It's just a little bit of shorthand. To get the position of a particular value, or the first position of a particular value from left to right, you will use the index method. So this looks like infolist dot index, and we'll get the first index of 7. So let's go through the list until it finds the first value of 7 and give us that number. In this case, that will be 0, 1, 2, 3, 4, 5, and then 6. So from this, we should see 6 as the value. Okay, let's add some print statements and see what happens. We are done with prints. It's all saved. Let's run this. Okay, so we have the count of 5 is 3 as expected. The length of the list is 8, and the index, or the position of the first 7 in the list, is at index of 6. This is useful if you want to do particular actions at a certain position within a list. Say that earlier you wanted to use insert, and you wanted to insert another 6 or a 6.5 between this 6 and 7. You could get the index of the first 7 and then use that as your basis for an insert. Okay, the final section that we're going to cover today is copying a list. And there are a number of ways that you can copy lists, so let's go ahead and get started with that. We'll call this section copying a list. As you'll know by now, I'm very creative with my namings. So we'll create a new list called original, and we'll do the list range again. So this will start at 5 and go to 12. So a direct copy of the method, we would do second is equal to original. So one thing to be careful of with this is that this isn't an exact copy of it. It's actually a reference to the same list. So second will point to the same exact list as original. So if you try to do any actions against second, those will also happen in original. So let's try this. Second dot append, and we're going to append 15 to it. So what's going to happen here, it's going to append the value 15 to second, which as we know is original. So when you print out second and original, they're both going to have 15 at the end of this. This is likely not something that you want. So with this, we have the method copy. So we'll call this one copy underscore 1, and this will be original.copy. So now we have an actual copy of the list where we can make actions against copy 1 that do not affect original, or in this case, don't affect original or second. So with this, we'll do copy 1 dot append, and here we're going to append a new list 1, 2, 3. So this append will only affect copy 1 instead of original or second. Another way to get a copy like this is to use what's called a splice. So we'll say copy 2 is equal to original, and then we're going to do the open and close square brackets with a colon in the middle. This is some new syntax that I'm introducing in this series. This is called a splice which returns a copy of a list. We're going to get more into splices later as they're part of a larger series. But for now, just know that this is going to return a copy of original, which we can then use in copy2. So with copy2, we'll do pop. And if you don't pass in a particular index, it's going to just pop off the last value there. So copy2 will then have the very last value popped off, and it doesn't affect original at the least. Now, one thing to be careful about with these copies is that they are what's known as shallow copies. Well, what do I mean by shallow copies? If we look up at our example above with the nested list, here we go, nested list, a shallow copy will just copy the outer list and not actually the contents of lists with inside of them. So it just copies the top level. And while you may still have the same values underneath, these are actually references to the same objects. So any action you take against this nested list or these nested lists will affect the original. So let's go ahead and do that and see what this looks like. So we'll call this nested copy, and we'll make this a shallow copy of nested list using the same annotation as we did before. So if we were to do nested copy and then take the first index and make this changed, that'll just change nested copy. But if we were to change something deeper, so if we go into one of our nested lists, this one will go into the deep nested one and change the value at the first index to changed, you'll see what happens. Okay, let me go ahead, add a bunch of print statements to this. We'll get this running and see what everything looks like. All of our print statements are now in place. Let's run this, give ourselves a little bit of room, and then we'll see what happened. Okay, so we see that we have our original, which is 5 through 12. And then the second, after we appended 15, now we see 15 at the end. But since it was referencing original at the same time, we now see 15 at the end of original. Okay, I forgot to put two print statements in here for copy 1 and copy 2, so I'll just do that. Save it, run it again, and here we go. So we see we have copy 1, which was a shallow copy, now has 1, 2, and 3 in a nested list at the end. However, original wasn't affected by that. Then we have copy 2, which popped off the last element, and we see that original wasn't affected by that. Now in our nested examples, we saw that we added changed inside the copy of the nested list, but the original wasn't affected. But when we added changed inside the nested list inside the copy, we see that it affected the nested one because it is not a deep copy, it's a shallow copy. Well, that wraps up this video. There are many more amazing things you can do with lists. One of my favorite being slicing. However, slicing is a larger subject that I'll be covering in depth in a future video. Today's code will be added to the Understanding GitHub repo, so check the description for a link. As always, if you have any questions or suggestions for topics you'd like me to cover, please leave a comment down below. To keep up with the series, please consider subscribing. Thanks for watching.